All right, Algebra 2 students, I am going to do my best to make this video less than 30 minutes. So everything we talked about in the previous video, the rational root theorem, was all about skills to help us deal with polynomial functions. So we can factor them. So let's take a look at factoring polynomials. One of the things we didn't stress in the last unit was looking for a common factor. So these three examples are all things you can factor if you notice that each term has a common factor. So in this first one, it's an x. If I factor out that common factor of x, I'm left with a quadratic that we should know how to factor. What are the factors of 5 that have a difference of 4, 5, and 1? If this is a negative 4, I need a negative 5 and a positive 1. Good. What about here? They both have a common factor of 3y cubed. When you take that out, you're left with y squared minus 16. Recognizing y squared minus 16 as a difference of two squares, so this factors to y minus 4 times y plus 4. And then in this last example, noticing the common factor of 5z to the second, taking that out, I'm left with z squared plus 6z plus 9. What are the factors of 9 that add to 6? Noticing this is of the form a squared plus 2ab plus b squared, and you get z plus 3 times z plus 3, or z plus 3 squared. So all the factoring we did in the last unit of quadratics, we need to remember, because we could also get that by taking out common factors. Here's another special form to look at called the sum of two cubes and the difference of two cubes. I don't memorize this formula. You're welcome to memorize it. I kind of have it memorized because I teach math, but let me show you why you don't need to memorize it. X cubed plus 8. If you just recognize this as a sum of two cubes and see that the first factor would be x plus 2, because 8 is 2 cubed, then what you can do is put a negative 2 here. Let me fix that. Put a negative 2 here. Write the coefficients of the cubic polynomial. 1, drop the 1, multiply by negative 2, add, get negative 2, multiply by negative 2, get positive 4, add, get 4, multiply by negative 2, get negative 8, get 0. And then you can say, oh, this factors to x plus 2 times x squared minus x, minus 2x plus 4. It is worth pointing out that this internal quadratic here does not factor. It gets a little messy if I give you something with a difference of two cubes like this, 9y cubed, 27y cubed minus give me another cube, 64. So that one's a little annoying because you have to remember that the 0 here that would work would be 4/3. And in that case, 27, 0, 0, negative 64. You're going to get that common factor of 3, so drop the 27, multiply by 4 nines, get 36. Drop the 36, multiply by 4/3. You're going to get 48. Add those up, 48. Multiply by 4/3, and you're going to get 64, and that's a 0. So you'd have this x minus 4/3 times 27x squared plus 36x plus 48. And then you take out the common factor of 3. And then I'm just going to work over here because I'm running out of space. That would be 3 times x squared plus 12x plus 16, I believe. 3, this would be 9x squared, excuse me, plus 12x plus 16. And then there'd be this x minus 4/3 that comes along, multiplying this 3 in here, and you get 3x minus 4 times 9x squared plus 12x plus 16. So if you want to memorize these terms, because that's going to be hard for you, great. A lot of times you just see it like this, and you can always do synthetic division to get those forms back. Okay, more examples. More examples. Recognizing this as 4x squared minus 9 squared. So that gives you 4x squared plus 9 times 4x squared minus 9. And then recognizing this as 2x minus 3 times 2x plus 3. A sum of cubes does not factor, so this just comes on down as 4x squared plus 9. So, factoring polynomials, looking for special forms. What about this one? You might notice the 8, the 4, the 32, but there's no common factor. So I've lost my notes here. I thought I had them with me, so here we go. It's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32. So those are my guesses. I always start with 1 and negative 1 because they're the easiest to check. So 1, negative 8, negative 4, 32. Okay, so drop the 1. 1 times 1 is 1, and that gives me negative 7. Multiply here, get negative 7, get negative 11. Nope, that's not going to work, so that's not it. Let's try a different number with a different color. 1, that's a 2. Get negative 6, that's a negative 12. Add that up. That's negative 16, and we found it. Negative 32, 0. Let me just double check the math here. 2, 1, negative 8, negative 4, 32. I'm doing it again for you to see. Drop the 1. 2 times 1 is 2. Add these up, get negative 6. Multiply by 2, negative 12. Add those up, get negative 16. Multiply by 2, get negative 32. Get a 0. That 0 tells you x minus 2 is a factor of this polynomial, and what you're left with is x squared minus 6x minus 16. And are there factors of 16 that have a difference of 6? Yes, I think 2 and 8 do. And then you've got this x minus 2 still coming along. That would be a plus, that would be a minus. And just look, this polynomial, if it was a function, would have 3 rational zeros, and the zeros would be plus and minus 2 and positive 8, all of which showed up in the 1, 2, 3, 4, 5, 6, 12 possible zeros. Good. All right, we're just factoring polynomials, moving right along. I don't see a common factor here, so then I list my possible zeros, 1 and 3. Start with 1 because that's usually the easiest. 1, 3, 0, negative 1, negative 3. Do not forget the 0 to hold the place of the x squared term, which is not there. Drop the 1. 1 times 1 is 1. Add these up. Get a 4. Multiply here. Get a 4. Get a 4. Multiply again. Get a 4. Get a 3. Multiply by 1. Get a 3. And we've got a 0. So great. I got one factor, x minus 1. But now I have this, x to the third plus 4x squared plus 4x plus 3. I got to keep trying to factor this. So instead of starting over at the beginning looking for another factor, I'm going to continue my synthetic division here. I really hope negative 1 works, but let's see. 1, negative 1, that gives me 3. That gives me negative 3 multiplying here. That gives me 1. That gives me negative 1. No, that didn't work. All right, so we start again. Let me try positive 1. Maybe it's a double root. 1, 1, 4, 3. Notice I'm not going back to the beginning because I already have factored out something. I'm dealing with this cubic that doesn't have a factor. Drop the 1. That's not going to work. And I can tell right away because this is positive, I'm going to need a negative. So I'm actually going to try negative 3 next. So negative 3 here, that gives me a 1. Multiply here, give me a negative 3. That gives me a 1. Multiply, get a negative 3. That gives me a 0. There we go. I've got x minus 1. I've got x plus 3. And now I have x squared plus x plus 1. There are no factors of 1 that add to 1, so this is completely factored. If this was an equation that I was trying to solve for 0, I would get x equals 1, x equals negative 3, or x equals the opposite of b plus or minus the square root of b squared minus 4ac. That ends up being 1 minus 4, which is negative 3, all divided by 2. So I get these other zeros are negative 1 plus or minus I root 3 over 2. So look, this fourth degree polynomial, if I had set it equal to 0 to solve, has 4 zeros. 1, 2, and then the 2 complex zeros. All right, moving right along. Oh, this is one of my favorites. How do you see this? How do you see this polynomial? Because depending on how you see it is going to get you how you factor it. I see it as x cubed squared minus 8 squared. Once you see it that way, you know it's going to factor to x cubed minus 8 and x cubed plus 8. And now what do we have? We have a difference of cubes for each one. So this one's going to be x minus 2 times x squared plus 2x plus 4. The other one's going to be x plus 2 times x squared minus 2x plus 4. So the memorization that I do have is I know it goes a minus b for a difference of cubes. And I know, and here let me do the right colors. I know it goes a minus b for a cubed minus b cubed. And then I know with the second one, a cubed plus b cubed, it goes a plus b. And then the other thing I do have memorized is it goes a squared, ab, b squared. And the signs go minus, plus, plus, or they go plus, minus, plus. So I know this one went a squared minus ab plus b squared. So I kind of lied to you. I do have that form memorized, but there you go. I think that's pretty much it for the examples. Because this is a super short video compared to last week's or last night's, I strongly encourage you to look through these examples again. All right, so look at how taking out a common factor works. Look at how you can use these two special forms to factor things that look like a sum or difference of cubes. Look at how we found a special form in here twice. Look at how we use the rational root theorem to factor here. Rational root theorem to factor there. How we use two special forms to factor this. I think there's one more. I thought there was one more. No, it looks like we're out. Okay, that's the end of the show. Have a great weekend. Peace. Sorry the videos were so long, but you guys whine so much. Peace.